Some, if not all, of the most fascinating discoveries would not have been possible without the use of technology, from space probes to rovers to radio and light waves. Let's take a closer look at how the science behind interstellar exploration led to the knowledge and advancements we know today. Here are some discoveries we wouldn't have without space travel. Einstein's theory of general relativity, proposed in 1915, expands on space and time, which he initially theorized in 1910. However, Einstein didn't consider gravity, and he discovered that massive objects warp space-time through gravity. General relativity mentions how wormholes are curved regions of space-time that connect two distant points like a tunnel. If anything were to pass through, the tunnel would collapse, and the matter would be cut off and disappear, trapped in whatever remote part of space the wormhole led to. However, some scientists have theorized that there is a way to keep wormholes open and prevent their collapse through the use of negative mass, or electrons, to counteract the electric charge and mass of the wormhole. Another theory is that by layering the wormhole entrance with shells of regular matter, the tunnel would be stabilized and allow matter to pass through. The researchers who proposed these discoveries plan to test the theories experimentally. If proven true, our greatest sci-fi dreams of time travel would come true and challenge our understanding of the universe. NASA's InSight lander, launched in 2018, has measured 3 separate quakes on the Red Planet. It was a close call for the lander to even detect these Mars quakes, though, due to the planet's elliptical orbit taking it farther from the Sun, causing InSight to use heaters to stay warm and not receive even solar energy in its panels. As InSight approaches the Sun again, its energy levels can rise and continue to gather data on the Red Planet. Scientists discovered 4,324 exoplanets in 2020. But in September 2020, a giant Jupiter-sized planet, called WD-1856b, was found orbiting a white dwarf star. Even though this star is a dwarf, it's actually 40% larger than Earth. Dwarf stars are the dense leftovers of a Sun-like star that has emitted all of its energy, swollen, then ejected its outer layers, losing up to 80% of its mass and leaving only a dense core. Somehow, the planet 7 times larger than the dwarf star got extremely close and managed to stay in one piece. WD-1856b resides in the constellation of Draco and is 80 light-years, or 25 parsecs, from Earth. While mining asteroids is a trope in science fiction novels, primarily for the galaxies that have used up a planet's resources and look for other options for fuel, it may just become a reality. The OSIRIS-REx spacecraft launched in 2016 and traveled to the asteroid, Bennu, which is close to Earth. The purpose of this mission is to collect a sample of rocks and materials from the asteroid's surface to better understand its chemical makeup, how life and planets form, and if asteroids hold material that Earthlings might find viable. In September 1977, Voyager 2 was launched with the same objective of exploring our solar system's outer limits and the impact of the Sun's reach. The Voyager spacecraft traveled at about 38,000 miles per hour, or 17 kilometers per second. Since their launches over 40 years ago, the two have discovered ice-covered moons, deep space volcanoes, and evidence of water on other planets. Jupiter's moon, Io, has a volcano with 10 times more activity than the volcanic activity on Earth. They are the first flyby crafts to travel interstellar space. In 1971, Stephen Hawking proposed the theory that black holes can't decrease in size over time, also known as the black hole area theorem. After 50 years of being proposed, researchers in 2021 finally proved Hawking's theory by analyzing the gravitational waves produced by black holes. Scientists calculated the surface area of the two holes before and after they merged and discovered that the area was greater than the sum of the two separate black holes. It even led to two physicists theorizing a method to safely and efficiently extract energy from black holes. It's hypothesized that this could be accomplished by breaking and reforming magnetic field lines at black holes' boundaries, making it possible for matter such as light to escape. Without space travel, we never would have discovered that 5,200 tons of space dust are added to Earth every year. Space dust is visible in the sky and is otherwise known as zodiacal light that diffuses a faint glow often seen at sunset or sunrise. Over a 20-year study, scientists gathered data of what and how these particles were occurring. Space dust consists of comet, asteroid, and interstellar dust passing through the solar system. A group of scientists got together and conducted a decade-long research mission using radar to bounce light waves off of the planet to measure its axial tilt, the size of its core, and how long it takes to complete an orbit. If scientists ever want to send missions to Venus, the spin and orbital length must be exact, otherwise, a spacecraft could land 20 miles off course and severely impact the mission. The research team discovered that one day on Venus is the equivalent of 243 Earth days and some change. In 2021, scientists discovered a new tiny galaxy, only 1% of the Milky Way's size. Still, scientists were able to find it by gravitational lensing, where large objects bend and magnify light, which creates a sense of what is there and what is not, like a photonegative. There are actually 20 dwarf galaxies floating around in the Milky Way, but finding them wouldn't have been possible without the minds and technology behind space travel. So they started looking at beauty quarks and the process of their decay, which just so happens to create a set of light particles through the weak force. Though this discovery still requires more data, researchers are on the brink of discovering a fifth element that could forever alter our understanding of physics.